Good morning, everyone. Welcome to AI Minute Mondays, where I take a couple of minutes each Monday to demystify AI for everyone. This week, joining me is Sathish Krishnan, who's the executive director at and a distinguished engineer at UBS. So he's going to help us unpack a key topic, LLM self-hosting. Before we begin, Sathish, can you share a little bit about yourself?
Thank you. Yeah, hi. I'm leading platform engineering and AI engineering at UBS. One of my key focus area is how we can run large-scale applications on cloud-native platform like Kubernetes, and now starting to look into how we can power AI applications, specifically agents and MCP tools and servers, and then build a platform around it that allows us to build or bring a non-deterministic component into a deterministic business process, and then also make sure that we are able to do it efficiently.
Thank you, Satish. I'm sure everyone is excited to hear from you. So let's go ahead and delve into the topic, LLM self-hosting. What are your thoughts on this? Why do we need this? And why are some teams moving away from hosted APIs?
Yeah, I think when we started AI, we wanted speed because we wanted to know how good this technology is. And that's where I think some of the providers were really good in offering this as a service, which we could use. But as the demand is increasing, moving from retrieval augmentation to agentic, where you have AI agents that are running in loop, trying to do operations or automate certain steps for you, we don't really know how much would it cost me, or how many requests are going to be going against what data it's going to take outside my premises, right, and what is coming inside my premises. So there's a lot of unknowns, and I think that's where we are starting to see that there are slowly folks moving away from, not away from, we will leverage hosted models, or I mean service provided models for powerful reasoning capabilities, or the knowledge that they have. But anything that's domain specific, where I know what is needed and I need to probably add additional context to the model and then probably tune the model for my specific requirements, a lot of this could be achieved with smaller models, and we could achieve more efficiency, more control, and basically all you can eat tokens. We don't have to worry about token limits and other stuff. So it becomes much easier. It's similar to how we used to do software. There was SaaS component, and there are a platform as a service component where we had control on how we run platforms. And not every platform is similar, though they are built on the same components. So that's where I think we are slowly seeing traction where yes, AI is good, but as we start productionizing AI, maybe I need more control, and that's where self-hosting comes.
Thanks, Satish, for those inputs. So yes, definitely, like you mentioned, self-hosting for areas where you need more control definitely makes a lot of sense. But then it's not all roses.
Right.
You need to have serious infra capabilities like Kubernetes orchestration, GPU management, model versioning, a lot of these areas. So can you kind of talk through some of the aspects in terms of what are the key considerations if you were to basically go ahead and self-host, and what, in your opinion, makes it worth it? What are the
Right.
top?
Right. Yeah, I think LLM or AI applications are different from regular applications that we are running. Even if you're running on a containerized platform like Kubernetes, where you could package more than one Docker container into the same virtual machine, have it share resources with each other. Unlike that, the GPU powered workloads, in our case, the large language model, would require an entire GPU allocated for it. And sometimes one GPU is not sufficient. You may need multiple GPU. And there are calculations based on which we arrive at that number. So if I take an example, most common large language model, like if we take Llama 70 billion as an example, these models, when they publish the weights, they publish it in a quantization format. The standard right now is FP16, which means if I have a 70 billion model, the weights or the size of the model is going to be times 2, which is 140 gig. And a typical GPU, like if I have to use A100 as a GPU, has 80 GB of memory. And because of the way GPU does parallel processing, in order to do efficient inference, you need all the model weights loaded into the GPU memory. Now, okay, so I have a GPU in A100, which has maximum 80 GB, but the model weight is 140 GB. So I cannot put 140 GB in a 80 GB RAM. So what options are available? And in the GPU or the LLM hosting community, like VLLM, they built ability to host your large language model across multiple nodes. They call it as pipeline parallelism, where you can have one model served from two different VMs. So now what it allowed me to do is I could have 140 gig, the model size, and 160 gig is the GPU size, combined GPU size. I could load the model, which is good. Okay, now the model is loaded, but in order to serve the model, I need to do a lot of processing, which means I upload a document, I upload a source code, and I want the model to process. That model does something, it uses something called as KV caching, key value caching. So every input that comes in goes through an encoding process. It converts that into a corresponding value, which is called as token. And the token is used for further predictions that the model performs. And it requires capacity for that. So if you say 120 G or 120 token length, we are talking about somewhere additional 20 to 40 GB of additional VRAM capacity. And if you're trying to serve across multiple users, 100 or 200 users, which means they are going to access the service parallelly. So you need to have enough capacity to serve all of them. And that impacts how much tokens you are able to process at a given point of time. So suddenly what happened is you have two GPUs, which is 160 gig, and your model weight is 140 gig. But in order to efficiently serve with 120 token limit, or we got as context window, you need additional 40 gig. So, okay, I cannot do that with two GPUs. So I will need three GPUs. So now suddenly my GPU recommend went from 80 to 160 to 240. Now maybe, okay, when I do three GPUs pipeline parallelism, first of all, I need to know if there is a VM available, SKU available in Azure. We use Azure, which can offer this combination. So Azure supports 1, 2, or 4. So I go with the combination that gives me 4 A100 GPUs on one node, and I try to distribute the model weights across this one. So just for 70 billion model, these are the complexity that is involved in itself hosted LLMs. And if you talk about hosting a very large model like DeepSeek, which is 630 billion, now you're talking about spreading a model across not just multiple GPUs, but even across multiple VMs, right? But again, not everyone has to go through this. Most of the enterprises will probably deal with small models, 8 billion model or 3 billion model and stuff. So in that cases, model hosting becomes easier. But what we often see is 8 billion model has limited knowledge, 70 billion knowledge as a model as a broader knowledge. So if you're using a model for your agents to take decisions, the bigger the model, the better your decision is going to be. So yes, we will have domain specific, task specific models, but then you will also have a broader model that is helping you in better decision making process.
Thank you for those brilliant insights, Sathish, and for explaining it so beautifully. So to summarize, self-hosting smaller models is much easier. Self-hosting the LLMs is more complex, requires more of thought that you're looking at. And when you're looking at domain-specific models, that's what the SLM would be more catered towards. So thank you for sharing those insights. And just to summarize, to remember, it's not just all about tech. It's about your business requirements. It's about how much you want to focus on trust, control, and overall long-term value. Exactly. And in terms of making sure that you have the right decision for your requirements. Yeah. Thank you so much, Sathish, once again for joining us and sharing those valuable insights. Happy to have you here on AI Minutes.
Thank you for the opportunity. Bye.